Hey guys, so this is Miss Dupe today, and we are going to learn about perfect squares and perfect cubes some more. So on Friday we had a little bit of an introduction, and today we're actually going to get into using the calculator. So right now, if you don't have anything, you need your calculator, a pencil, and a notebook piece of paper to write these examples down on. If you need to get those things, pause this and go grab them. So we're low tech today. I have our examples written down on here, so we're just going to go little by little through these. So first of all, you learn the definition of perfect squares, which perfect squares are whole numbers whose square root is also a whole number. We don't really know what a square root is yet. We kind of talked about it on Friday, so we're really going to learn about it today. The square root is the inverse operation of squaring something. You guys might have squared already in 7th grade last year, but this year we are definitely going to square, and we're going to square root here. So these are our first three examples here. If you want to go ahead and write them down, we have 2 squared, 5 squared, and 10 squared. And the squared is the little tiny number up here. Whenever you have a 2, that means you're squaring something. So first of all, squaring is the same thing as just multiplying a number by itself twice. So this first one, we're really just doing 2 times 2. So these two things right here are the same exact thing. But once you start cubing, which we're going to do next, it makes things a little bit shorter in the calculator. So how you square this in your calculator is you are going to hit 2, and then you're going to hit this x squared button here. The x squared buttons give you the tiny little 2 that tells you you're squaring something. Everybody's texting me. And you hit enter, and you get the answer 4. So our first example for 2 squared, the answer is 4, which you probably already knew that because you would know that 2 times 2 is 4. So the next one is going to be 5 squared. Again, it's super important to make sure you're putting these in your calculator. So you're going to hit 5, and then the x squared button to give you the tiny 2, and then hit enter. So 5 times 5, 5 squared is 25. So we're going to write that down for our next one. We have 5 squared is 25. Our last one, we're going to find 10 squared. So we're going to type in 10, hit the x squared button, hit enter, and we get 100. So 100 is 10 squared, which is 10 times 10. So those are our first 3 answers we have here. Now taking the square root is just trying to go backwards from that. So we're trying to figure out what 2 numbers multiplied that are exactly the same to get these numbers here. So with perfect squares, the answers are always going to be 2 whole numbers. It's going to be like 8 or 6 or 2 or whatever. So our first example is going to be the square root of 64. So to do this in our calculator, we are going to use the second button. You know you're in second mode because the second shows up at the bottom of the screen here, and then you're actually going to hit that same x squared button that we were using for squaring, which kind of makes sense since taking the square root is the inverse operation of squaring. So now we're going to type in 64, and we're going to hit enter. Let's redo that. Let's do second x squared 64. I want to make sure I'm getting all my keys right, and then hit the parentheses button. That's very important to put that parenthesis in there for later when you're doing like multiple things at the same time with roots. So then you're going to hit enter, and the square root of 64 is 8. So what this is telling us is that 64 is a square root because this answer is a whole number, and it's also telling us that 8 times 8 is 64. So we're going to write that down on our piece of low-tech paper here today, and we know that the square root of 64 equals 8. So our next example is going to be the square root of 144. So we're going to get our calculator, hit second, and the x squared button, and then 144. We want to make sure to close that parenthesis here and then hit enter. So we're getting 12 for this one. So that means that 12 times 12 is 144, and we also know 144 is a perfect square because we're getting a whole number as that answer. So our next answer, we're going to write down 12. On our paper, I like to circle my answers just because it's easy then to see the end of my work there. So the next one, we're going to take the square root of 9. Again, you're hitting second, the x squared button, and then number 9 here, we're going to close our parentheses, and then we're going to hit enter, and we get 3. So 3 times 3 is 9, and 9 is definitely a perfect square because we are getting a whole number as that answer. So here's that one right here. Now our last two examples are going to involve negatives. So weird thing about square roots is that the placement of the negative counts. So this first one we're going to do here, the negative is outside the root, which means when you type this in the calculator, you're going to put in the negative first. With the calculator, I know in math, the negative in subtraction is kind of interchangeable, which is true, but in the calculator, this is 100% the subtraction button, and this is 100% the negative button. So if you have a negative number that you're putting in first, you want to use the negative button, which is kind of shorter than the minus button. You're going to hit second x squared to get the root. So this placement matters here. The negative is on the outside of the root, and now we're going to type in that 25, close the parenthesis, hit enter, and we get that the answer is negative 5. Now, if we think about this, we know that positive 5 times positive 5 is 25, and then if we put the negative in front of there, it makes it a negative 5. The last one we're going to do, the negative is underneath the square root. So when you put this one in your calculator, you are going to actually put the root in first. So you're going to hit second x squared. The negative is definitely underneath the root this time, so it's going to go inside that parenthesis. 4 is what we're finding the square root of, and we're going to close our parentheses. Now when we do this, we get a domain error. That's because we cannot take the square root of a negative number. So the placement matters. Your calculator will always tell you if you're allowed to do it or not. If you're not allowed to do it, it'll say domain error. If you are, then it will give you an answer, and it will be negative. So for this one, you can put undefined as your answer. And so here's all our notes for perfect squares. So then next we're going to go to perfect cubes. Alright, so next we're going to talk about perfect cubes. Same thing, low tech on this paper here. And the definition for perfect cubes we also went over on Friday. Perfect cubes are whole numbers who, when you take the cube root of them, they're also going to give you a whole number. So cubes and cube roots are very similar to squares, except they have the number 3 instead of the number 2 for the exponent, and then you also have a tiny 3 on the outside of the root here. So that's how you know the difference. So with cubes, they're just one up from squares basically. So instead of multiplying a number by itself twice, you're doing it 3 times. So this would be 3 times 3 times 3. But instead of typing all that in the calculator, it's really easy to just type the cubed in the calculator instead. I just smeared my pen. So I'm going to show you how to do that first. It's a lot different for cubes and cube roots in the calculator than squares and square roots. So 3 cubed, you're going to type in the 3 first, and then you're not going to hit this x squared button anymore because we're doing a cube. We're actually going to hit the caret key button, which would allow us to put any exponent in here, but we're going to type in 3 because 3 is the cubed exponent. And we're going to hit enter, and we get 27 for 3 cubed. So we're going to write that down in our notes here. Oops, and I made a mistake. And we have 3 cubed equals 27. So our next example, we're going to do negative 5 cubed. So a negative 5 cubed, since we're starting to work with negatives now, we're going to hit this negative button here, hit 5. The caret key is how we get our exponent or our cubed, and then we're going to type in 3. We get negative 125. So what this is telling us is 5 times 5 times 5 is 125, but we have a negative 5 times a negative 5 times a negative 5, so that gets us negative 125. So our last example of cubing numbers is going to be 10 cubed. So we're really finding 10 times 10 times 10, but instead of typing that all in the calculator, we're going to get hits 10. My brain is so scrambled. Caret key, 3. Hit enter, and we get 1,000. So 1,000 is 10 cubed. Once again, make sure you're writing this down, circle your answer. We got 10 cubed is 1,000. So now we are actually going to cube root, which, similar to square root, it's the inverse operation of cubing. So this is done completely different in the calculator. You're definitely not going to touch that x squared button for this either to put the root in. Our first one is cube root of 27. So let's clear out our calculator. For cube root, it has that tiny little 3 in front of the root. So we're actually going to type in the 3 first, and then we're going to hit second, and then the caret key button. So just think everything with cubes is done with the caret key button, and everything with squares is done with the x squared button. Now we're going to type in 27. The difference between cube roots and square roots is that it doesn't give you the little parenthesis with the root, so you don't have to type the parenthesis at the end for this one. You're going to hit enter, and the cube root of 27 is 3. So what we're finding is that 3 times 3 times 3 is 27, and 27 is a perfect cube because we're getting a whole number for our answer. So we're going to write down 3 here. We got it in our notes, and we're moving on to the next one. So we're doing cube root of 1,331, which seems like a big number, but it really doesn't come from that big of a number. So we're going to hit the 3 first, second, caret key, and then 1,331. We're going to hit enter, and 11 is our answer. So 11 times 11 times 11 is 1,331, and this is a perfect cube because the answer is a whole number, not a decimal. So there's our answer there. Last two examples are going to involve negatives. So with square roots, it matters where the negative is. For cube roots, you'll see what happens. So we're taking the cube root of negative 64. The negative is underneath the root. So we're going to put in the cube root first, and then we're going to type negative 64 and hit enter. It gives us negative 4. Now if we were doing the square root and we had the negative underneath the root, this would say domain error. So that's a big difference between cube roots and square roots. So we got negative 4 for that example. And then the very last one, we're going to have the negative outside the root, which means we're going to type the negative before everything. So we're going to type negative and then 3 for the cube root. Put the root in the calculator. And then we're doing 343. 343. Hit enter. We also get a negative number for this one. So just remember, for cube roots, whether it's inside or outside the root, it is going to be negative if that negative is there. Alright, that is it, guys. Thank you so much for watching. Make sure you do the assignment, make sure you have these notes, and let me know if you have any questions. Bye!